What was there before humans? A question that has puzzled many minds and sparked countless debates. Let's start our journey at the very beginning, with the Big Bang. Picture this, a singularity, an infinitesimal point in space brimming with energy. This is how our universe began, approximately 13.8 billion years ago. An explosion of incomprehensible magnitude, a Big Bang, set everything into motion. In the blink of an eye, the universe began to expand, not into an empty space, but creating space as it grew. It's a bit like blowing up a balloon. As you inflate it, the surface expands, creating more room for the air inside. That's similar to how our universe expanded, but on an unimaginably larger scale. And in all three dimensions. Now, what's the evidence for this colossal event? Enter the cosmic microwave background radiation. This is the afterglow of the Big Bang, still detectable today. It's kind of like the embers of a campfire, still warm long after the flames have died down. This radiation permeates the entire universe, a relic from its fiery birth. Speaking of fiery, let's talk about the temperatures at that time. We're looking at a mind-boggling 1,000 billion degrees Celsius. That's hotter than the core of our sun. It's so hot that atoms couldn't even form yet. The universe was a seething soup of energy and fundamental particles. Gradually, as the universe expanded, it began to cool. This allowed atoms to form, which eventually led to the creation of stars, galaxies, and everything we see around us today. So before there were humans, there was a universe, rapidly expanding and cooling, setting the stage for the formation of galaxies, stars, and ultimately, life. Now imagine in this vast cosmic soup, our Milky Way galaxy began to form around 13.6 billion years ago. Picture an enormous cloud of gas and dark matter, spinning slowly in space. This cloud was the birthplace of our galaxy, a region of the universe rich in the elements necessary for star formation. But how does a cloud of gas and dark matter become a galaxy? The answer lies in the unseen forces that govern our universe. As gravity began to pull the particles of gas and dark matter together, the cloud started to collapse under its own weight. This process, known as gravitational collapse, is a fundamental mechanism in the formation of structures in the universe. As the cloud collapsed, it began to spin faster and faster, much like a figure skater pulling in their arms to spin more quickly. This spinning motion caused the cloud to flatten into a disk, setting the stage for the formation of stars and planets. Within this spinning, flattened cloud, regions of higher density began to form. These dense regions attracted even more matter, growing hotter and hotter as they did. Eventually, these hot, dense regions reached a critical point. The pressure and temperature became so extreme that hydrogen atoms began to fuse together, releasing a tremendous amount of energy. This process, known as nuclear fusion, marked the birth of the first stars in our galaxy. These new stars, with their intense heat and light, began to push away the remaining gas and dust in the cloud, clearing out regions of space for the formation of planets. Over time, billions of stars and planets formed, creating the complex spiral structure we associate with the Milky Way today. But the story of our galaxy doesn't end there. The Milky Way continues to evolve, as new stars are born and old stars die. This constant cycle of birth and death, driven by the forces of gravity and nuclear fusion, ensures that our galaxy remains a dynamic and vibrant part of the universe. And just like that, our cosmic address, the Milky Way, was born. Fast forward to 4.6 billion years ago, when our very own Earth was formed. The birth of our planet is a tale of cosmic proportions, a story that begins with a cloud of gas and dust, the solar nebula. This nebula, a swirling maelstrom of particles, began to collapse under its own gravity, forming a spinning disk of material. Within this disk, small particles began to stick together, gradually growing into larger and larger clumps. These clumps, or planetesimals, eventually combined to form the planets in our solar system, including Earth. Now let's delve into a rather dramatic chapter in Earth's early history, the collision theory. This theory suggests that around 4.5 billion years ago, Earth had a fateful encounter with a Mars-sized body known as Theia. The impact was so colossal that it sent a huge amount of debris into space. This debris eventually coalesced to form our moon. The early Earth was anything but hospitable. With temperatures reaching up to thousands of degrees Celsius, it was a world of molten rock, a fiery hellscape. This was the Hadean era, aptly named after Hades, the ancient Greek god of the underworld. But even in these extreme conditions, the foundations for life were being laid. The heat drove out gases trapped in the rocks, forming the Earth's early atmosphere. Over time, as the Earth cooled, water vapor in the atmosphere condensed and fell as rain, filling the basins to form the oceans. Frequent meteorite impacts also played a crucial role in shaping the Earth. These celestial intruders brought with them water and organic compounds, essential ingredients for life. The bombardment also stirred up the Earth's crust, leading to the formation of tectonic plates. And from this chaotic period, Earth emerged, a blue marble in the vastness of space ready to nurture life. The stage was set, and the curtain was about to rise on the grand drama of life's evolution. But that's a tale for the next scene. But how did life, and ultimately humans, come into existence on this blue marble? This question has puzzled scientists for centuries. Theories abound, each as fascinating as the other. Let's begin with the primordial soup theory. Around 4 billion years ago, Earth was a hot, volatile place, with an atmosphere rich in methane, ammonia, water vapor, and other chemicals. These elements, sparked by lightning or volcanic activity, could have formed the basic building blocks of life: amino acids. This soup of organic molecules over the course of millions of years may have given birth to the first simple life forms. Picture tiny unicellular entities, struggling to survive in the harsh conditions of early Earth. These are our oldest ancestors. Yet, there's another intriguing theory: panspermia. It proposes that life didn't originate on Earth at all. Instead, microscopic life forms, or the ingredients for life, may have hitched a ride on comets or meteorites, eventually crashing into Earth and kickstarting life here. From these humble beginnings, life evolved, becoming more complex and varied. Around 600 million years ago, the first multicellular organisms emerged. Fast forward another 100 million years, and we see the first primitive animals making their appearance. Now let's talk about us, humans. We're part of a lineage called hominids, which first appeared around 6 million years ago. Our journey wasn't a straight line, but a branching tree of evolution, with numerous species, some of which went extinct, and others that survived and evolved. 2 million years ago, our genus, Homo, emerged. Homo habilis, with their increased brain size and use of tools, marked a significant step towards our species. Homo erectus, our direct ancestors, started using fire and living in complex social groups. And finally, around 200,000 years ago, Homo sapiens, that's us, came into being. And so, from cosmic dust to living beings, we've journeyed through billions of years of cosmic history. So what was there before humans? The answer to this question takes us on a mind-boggling journey through time and space. We've ventured from the very birth of the universe, the Big Bang, a singular point of infinite density and heat, expanding and cooling over billions of years to form the cosmos as we know it. We've traced the formation of our home galaxy, the Milky Way, a colossal spiral of about 200 billion stars born from the gravitational pull of dark matter and the cooling and condensing of cosmic gases. We've journeyed to the origins of Earth, a planet forged from the remnants of supernovae, its fiery beginnings giving way to a hospitable environment for life over 4.5 billion years. We've followed the relentless march of evolution from the first life forms, simple single-celled organisms, to the complex symphony of biodiversity we see today, and the emergence of humans, a species with an unparalleled capacity for understanding and manipulating the world around us. These vast timelines, these astronomical numbers, they underscore the incredible journey of cosmic evolution, a journey that took almost 14 billion years, setting the stage for the grand drama of life. Before humans, there was a universe teeming with energy, galaxies taking shape, and a planet being crafted, all setting the stage for the grand drama of life and the arrival of us, humans.